Welcome back. We finally have some refresh after three male presenters. So next in line is Lucija Valentić from ReversingLabs. But don't let sweet face of Lucija fools you. Lucija is pretty dangerous, but luckily not for us, but for malware hiding in the NPM packages, PIP packages. So I'll let Lucija do the talk about the hidden threat in unmasking malware in machine learning models.
Thank you, Mislav. Hello. Thank you, everyone, for coming. I'm here to talk about how there is a way to hide malicious software inside machine learning models and how the way they're saved is the reason for it. For this presentation, I'm going to focus on Pickle, and we're going to show some examples and maybe tools with which you can detect those malicious Pickle files. This presentation was already held before, but I have added a few slides that are new with new research that we at ReversingLabs actually did. But first, let me introduce myself. My name is Lucija Valentić, and I'm a threat researcher at ReversingLabs. There, in everyday job, I'm searching for malicious software, malicious NPM packages. Up until last couple of months, I've been searching on VS Code Marketplace and Ruby Gems. So let's start. Of course, in the last couple of years, we have seen an increased interest in artificial intelligence with large language models being popularized. Of course, GPT-4 that powers ChatGPT being one of the most famous ones. We have now also seen some open source LLM models such as DeepSeek. I think also from French, they also release some open source LLMs and so on. And of course, companies and users alike are starting including those LLMs in their own applications and using them. So of course, people have started training models, being more interested in them, and they're trying to use them in their own applications. So of course, repositories such as Hugging Face or PyTorch Hub were created, which sort of serve repositories where you can open source repositories where you can store your models, you can share them with other people. Maybe if you want to just use them and not write models, you can find there. But of course, like with any open source place, potentially there are also some risks and vulnerabilities found there. And 2 years ago, Splunk did a research on risks and vulnerabilities on Hugging Face. They focused on Hugging Face because Hugging Face is currently the biggest one repository we can store malware. And what they found out, among other things, is that majority of models found there are pickle models. And that is a bit concerning since pickle is inherently unsafe and it's very simple to abuse it, to make it execute arbitrary code, and we will show some of the examples. But first, we will cover what are ML models. We're gonna cover how they're trained, what they're used for, very, very briefly, and then we'll say where comes Pickle in all of that. So ML models are type of mathematical models that are used for various functions. They are used for image classification, for example, file classification, for detecting malware, for price prediction, and so on. They're trained with using data sets called training sets. And with each iteration, weights of the model are being improved and they are being better and better at its function. And once the model is trained, once it performs well that function, it is saved without a question. And there are many reasons why you want to save your model. For example, maybe you are creating a big model you're training it on big data sets. So it takes, of course, time, a lot of time and computational power to train it. So of course, when you need it, you're not gonna, do it once and then scrape it and then do it again and then scrape it. You're gonna save it once, and then each time you need it, you're just gonna reuse it. Of course, sometimes maybe you want to share it with your team members because you are the person who trains ML models, but other will use it in their own functions, their own applications, whatever. You also maybe want to share it with community. You want to upload it somewhere, for example, on Hugging Face, because you really want to work with ML models, you really like math behind it, you really want to train it, but you don't want to use it, or you just want to be a good person, give it to community so they can, use for their own applications and, whatever. And of course, while you saving that model, you serialize it. And like with anything, you are using ML frameworks because you're not going to write everything by yourself. And different ML frameworks have different libraries for serialization and deserialization. And depending on which kind of model you're working with, which kind of module you're training, you use different ML frameworks, different libraries for serialization and deserialization. And here comes the most famous library that I have already mentioned, and that is Pickle, which is used by PyTorch. But what is exactly Pickle, and how can you find yourself in a pickle? So Pickle is a Python library for serialization and deserialization, like I have already said. And here we encounter two concepts, pickling and unpickling, or serialization and deserialization. And it's very simple. So in the process of pickling or serialization, you take a Python object hierarchy and you turn it into a binary system, pickle. And in the process of unpickling or deserialization, you take that binary system and you turn it back into a Python object hierarchy. Of course, if we want to understand why exactly pickle isn't safe, because it's not very now known, we want to look at its source code. We want to look exactly what happens in the process of pickling, in the various extensive commentary in its source code. But basically, in the process of serialization, that Python object hierarchy is turned into a series of opcodes that represent that Python object hierarchy, and that is called pickle. And in the process of unpickling, something called pickle machine that has stack and memo is interpreting that opcodes until last opcode is reached. Stop. And of course, there are various opcodes that do various things. Some are putting things on the stack, some are taking it off the stack. But two opcodes can be a bit dangerous. They're normal opcodes, but they can be abused to execute arbitrary code. And those are reduce and global. So they, in the process of unpickling, they invoke function reduce, which is, again, a normal function. In normal unpickling, it returns all necessary information for some object to be deserialized, to be unpickled. But because of how pickle works and how opcode works, reduce can also be abused to execute arbitrary code. Normally, reduce has a normal function. So basically, if you want to pickle your custom class, perhaps pickle won't pickle it, serialize it in a way you are satisfied with, or an error will get thrown. Because pickle has list of objects that pickles well, but sometimes, your custom class won't get through. So what you do, you tell pickle how you want your custom class, how you want your objects of that custom class to be serialized. And that can be abused, which we actually see in an example here. I have made very, very, very simple example just to showcase how easy pickle is to be abused. So I have made an evil class that I told pickle how I want that class, object of that class, to be serialized and deserialized. So what I did, I, of course, pickled it, unpickled it on Linux. And I got the host name of that computer very, very easily. And that happened because I told pickle with function reduce that I want, in the process of unpickling, that he returns to me function OS system with arguments host name. And that is, again, very simple example, but it showcased unsafetyness of pickle, and something very similar actually happened in real life. So we're going to look at next three examples, how function reduce was abused in real life or proof of concept to showcase unsafetyness of pickle and how there are malicious ML models on Hugging Face. So I think last year, JFrog found malicious ML model on Hugging Face that had reverse shells inside. So of course, when victim would use that machine learning model, when it would upload it, load it, use it, reverse shell would get executed, and of course, malicious actor would, without victim knowing, have an access to victim's computer. And it was very easy to inject that malicious payload inside machine learning model with just using function reduce. This example is another very simple example, very reminiscent to my previous one, but is a real life example that was found on Hugging Face. The next two examples we're going to look at are more proof of concepts, but they still use abuse function reduce to execute, to inject malicious payload. So so LLM models are turned malicious. So in this proof of concept, researchers at Hidden Layer found a way using steganography to inject ransomware inside of the weights of model. And then using function reduce, they injected malicious script that would, once model was used, once it was loaded, that malicious script would actually piece together ransomware. It was using steganography, it would extract back from weights, it would piece it together, and then in the end, it would execute it. So basically, they of course have written like three scripts, and only two commands are necessary for machine learning model that is normal to be injected with ransomware that would run once ML model was used, once it was loaded. The last example we're going to look at of malicious ML models and how Pickle is very unsafe is a little bit different. So researchers at Trilobits, they did a proof of concept once again, but they didn't try per se to inject anything malicious inside machine learning model. So usually large language models, among other things, are used for example, generative AI. So of course, when people are using them, they expect that informations are at least a little bit correct or not harmful. But what researchers at Trilobits did, they again abusing unsafetyness of pickle and abusing function reduce, they injected a script that would, once large language model was used, that script would change weights of the model ever so slightly, just a little bit. So once the model was used in some application or something, it would actually give out harmful information. And of course, drinking bleach as for health is very easy to detect, but that may not always be the case. And as we can see in these examples, Pickle is very safe, and this leaves us with the questions: can you detect those stuff? Can you detect if you think some Pickle, for example, is malicious or some ML model? And of course, there are systems and tools put in place. So the first tool that can be used is Fickling, developed by researchers at Trilobits. Even though Fickling is a little bit more on reverse engineering side, so if you want to play with pickle, you can inject malicious payload inside, you can do static analysis of it, whatever. You can also technically use it to detect if a pickle file is malicious with option check safely. So if that pickle is something is amiss, that pickle is perhaps malicious, Fickling will alert you that one function can be used to execute arbitrary code, and that pickle is mostly malicious. And here we have very again simple example that showcase the evidence of that. Another tool that can be used that, again, it's not strictly for detecting malicious pickle files, but it can be used, is Pickle Tools. So Pickle Tools is a Python library, and it's usually used for developers that work with Pickle because it gives you extensive commentary on Pickle and Pickle functions and how your Pickle actually looks like. But can also give you a symbolic disassembly of that pickle. So it gives you a list of opcodes that will get interpreted. Again, you still have to do your due diligence because it's not going to alert you, but you can perhaps catch if something is amiss. Another thing was actually set in place by Hugging Face. So if you're using Hugging Face, there are scanning for malicious pickle files. Of course, they have malware scanning where you upload like any open source repository, I think at least. Whenever you upload machine learning models, they scan it for malware. But they also have pickle scanning. So whenever you upload a machine learning model or you update it, they scan pickle files for all the imports, and they write out all the imports that are being used inside. However, you still need to check all those imports. Of course, they alert you if they know that some imports can be used to execute arbitrary code, as we can see in this example, function eval. But sometimes they do not actually check all those imports. So for example, if some user wrote PyPy package and pickle file used it in its import, of course, pickle scanning won't alert you to it. Pickle scanning, the tool that is used for pickle scanning is pickle scan that you can use locally. You can find it on GitHub. But with pickle scanning, when we did the research, we found another malicious ML model that actually evaded that pickle scanning. And I did lie when I said those examples were the only one. I'm going to show you another example that we found that my colleague Carlo did, and he wrote an amazing blog about it. But basically, he found a malicious ML model on Hugging Face, and inside it had reverse shell. It wasn't detected by pickle scanning because probably it was compressed with 7z. So PyTorch load couldn't load it, so it wasn't detected. But we also have noticed one interesting thing about pickle files that had malicious payload inside. And this showcased another reason and how easy pickle is abused. So those pickle files that had malicious payload inside that had reverse shell were broken. And you would think that if they were loaded, if they were used, nothing will happen because, it didn't, when you scan it with pickle scan, nothing returns, an error returns, but it shows that there were no malicious files. And if you try to load it, again, an error returns. But that is wrong because it has everything to do how pickle scan works and how actually unpickling works. So pickle scan, first, it checks if the pickle file is valid or not. If it's valid, if it's not, of course, broken, then it scans it, everything's fine. However, if it's broken, it's not valid, and an error gets thrown, and that's it. But it still returns that no malicious files were found. It still has that output. And if you try to unpickle it, because unpickling, that pickle machine works as interpreter, it doesn't check first if pickle is valid or not. It just starts to interpret those opcodes until last opcode is reached, or until, of course, some opcode that doesn't exist is reached. Which means that if malicious payload is before that breakage, it will still get executed no matter if unpickling returned error. So what Carlo did, and it's explained in his blog, basically he made an example, very simple example that had malicious payload inside, that is not actually malicious, it just creates a file, and he tried to scan it with pickle scan. Of course, because it's not a valid pickle file, he broke it. Of course, an error was thrown, but it also had an output that there are no infected files inside, even though that was incorrect. And when he tried to unpickle it, as you can see, again, an error was thrown. So you would think that nothing happened. But as I said, of course, all those opcodes were interpreted, so malicious payload was still executed. So that file that he created, he tried to create with that malicious payload, was still created. And this is another example how pickle is very, very unsafe and how easily it is to abuse it and to use it to execute any arbitrary code. And of course, that again leaves us with question: can you be sure that your models, your pickle files, if you download it from somewhere, can you be sure that it's not malicious? Can you be sure that if you download it from open source, that is 100% safe? Well, like with any open source software, if you're not going to write yourself, even in some cases that can also be tampered with, you're not always 100% sure that those models, those pickle files that you download are safe. So what you can do is, avoid loading models, using models or pickle files from untrusted sources. Even though we have seen that, Hugging Face is very popular open source model, LLM model repository, but still had malicious files. Another thing, how you can mitigate unsafetyness of pickle is to use some alternatives. Some maybe alternatives libraries or maybe some frameworks that do not use pickle. For example, Open Neural Network Exchange uses protobuf, which is safer than pickle. Not 100% foolproof, but it is safer than pickle because pickle is very easily abused. Another alternative to pickle are safe tensors. It is a fast and safe alternative to pickle developed by Hugging Face. And of course, Hugging Face, they really did their due diligence. So they have, of course, malware scanning, they have pickle scanning, they are trying to mitigate unsafeness of pickle. They also have safe tensors, and they also offer a way for you to convert your models that are, using pickle into a safe version of that are using safe tensors. Another thing that can be used is perhaps if you have, listened in the beginning, all those malicious payloads, all those malicious models, malicious payload was executed once the model was loaded, once it was used. So if there is a way, which there is, to customize unpickler, you can maybe stop or catch that something is amiss. And there is. For example, you have Krypton unpickler that does just that. You can override function find class and restrict all globals and imports that are being called. Because find class, in the process of unpickling, it returns, it gets invoked whenever some global is being imported. So of course, if you write unpickler by yourself, if you maybe restrict or ban some globals, you can maybe perhaps catch in the process of unpickling if something will happen and if something is amiss. However, I haven't mentioned it during the presentation, but all of those tools and all of those systems are not 100% foolproof. And I have told you, some alternatives to Pickle, but they are also not 100% foolproof. Because I have just showcased a couple of examples how Pickle is unsafe and how it can be abused, for example, with function reduce very easily. We have also seen that we have found broken Pickle files just abusing the way Pickle works. It would also, bypass Pickle scan, but it would execute arbitrary code, even though person would think that an error was thrown and nothing happened. Those conversion to safe tensors, for example, there has been research. I'm not sure if that was patched, but that conversion can be used to tamper with other models on the site. So that fact that I said, even though if you write it yourself, your own models can be still tampered with. Protobuf, it's not 100% foolproof. It is safer than Pickle, of course, because Pickle is very, very unsafe. It's so unsafe that even if you go to official documentation of Pickle, Python itself have wrote that Pickle is unsafe. But what I want you to leave you with is that all those open source models or open source software that I usually see every day, you have to be mindful before you use it, before you include it somewhere. There are tools, there are ways to mitigate risks, vulnerabilities. There are tools, and there are other people with expertise, and just in the end, be safe when you use open source software. And that is all for me. Thank you for listening. And if you have any questions, feel free to ask. I'll try to answer them the best way I can.
So is there any question for Lucija on this topic?
Molim, pokoriste. The open source, I should answer in English, right? Yeah. So for they use open source Pickle models. For developers, they don't, but if they use models, it's most likely that those models are using Pickle. So because Pickle is very, very used, and the most open source models that can be found are on Hugging Face, and as I said, like most models are Pickle. So it's just.
Is there any machine learning model to detect malicious machine learning models?
Well, technically, in-house, yes, we do have it.
Okay.
Hi. So if machine models are mainly data, why are we packing code?
We are packing it because I'm not sure, but I think because we want to compress it and reduce it in size. I'm not sure because I'm really not working with machine learning models, so you have to ask people who work with machine learning models.
Right.
I'm just focusing on Pickle here, so.
Yeah, I mean, the Pickle is basically just taking the whole object with the code and data, but the machine model is basically just data. So you could, compress the data and leave the object aside.
Yeah, I'm really not sure. I have to check because I'm not working with machine learning models, so I'm not sure. Like everything I said about machine learning models, I checked with our machine learning team. So I'm really not sure about that. I'm sorry.
Thank you.
So any other questions?
Do you think that it makes sense to dynamically analyze pickle files, like have a specific type of sandbox for like importing a pickle file, running it, and seeing what happens on the host system? Or is that something that already exists, or does it even make sense?
I'm not sure if it exists, but it could make sense because, for example, fickling can maybe alert you. But of course, there are, because malicious actors they are developing always new things, how to bypass some detection. So of course, if you do a dynamic analysis of it, maybe you can, catch something, what happens and so on. But I'm not sure if it exists. Maybe it does.
Okay, any more questions? So if that's it of questions, again, thank you, Lucija.
Welcome.